Hi, everybody. Thanks for coming. Matt Hansen. I work at a company called Element84. I'm from the northeastern United States. And I have been giving variations on the same topics for years. This is my 10th FOSS4G. I am still giving those talks this week. But this year I really wanted to do something different. I'm not an expert in AI at all. I think that we're all just at the stage where we're really just figuring this all out. But we need to figure this out. So this is really trying to start the discussion about what this means for open source software if everyone is a developer. It really is a brave new world. We have AI-assisted programming, and it's quickly changing how developers write, test, and maintain code. So this is really looking at how these coding tools are really pushing the open source ecosystem into really potentially two directions at once. Making it easier to generate new tools and forks of existing tools, and risking fragmentation in this ecosystem, but also creating, I think, strong incentives to build core software with a higher quality. So in Star Trek, there's this one episode where Commander Data creates himself as an artificial being. If you're not a Star Trek fan, creates a new android called Lal. And this creation, Lal, eventually exceeds the original capabilities, and she starts operating autonomously. She learns, she evolves, she acts independently, faster than she can be guided. And eventually she's overcome by a series of cascade failures, and she effectively dies. This is really a story about a new intelligence that's creating and building tools of its own. And that's really where we are now. We have tools that are building their own tools, often beyond our own oversight. Open source software really now is creating a new kind of pressure, and it's not the typical original pressures of funding or debates around standards. It's from code that writes itself. So while this shift really does affect the entire open source ecosystem, I think the geospatial domain provides a case study on what the role of subject matter expertise means in this new age of AI-assisted coding. So why does this really matter? Well, there's a real anxiety among conferences like this that AI is coming for our jobs. It's devaluing our work and replacing coding jobs. But I would like to argue that at least in the midterm, that the exact opposite is true. That true subject matter expertise, such as the folks in this room, are actually more valuable, not less valuable. But we do need to make the right strategic decisions going forward. For the geospatial community, which really straddles general purpose computing and domain-specific nuances, there is this key tension here. You've heard the term geospatial isn't special. This has gained a lot of traction, suggesting that spatial data should be treated like any other data. But AI-generated code often reveals that geospatial is, in fact, special. There's date lines, there's projections, topology, and the realities of messy data and edge cases that don't generalize very well. So AI coding tools like Copilot, ChatGPT, Claude, they are becoming default parts of how we scaffold, write, and test software. This isn't just autocomplete. This is a generative design. It's reshaping how we interact with software, where to look for solutions, which libraries to use, and how that code is written. These AI systems are creating new abstractions and frameworks faster than human oversight can review them, creating a new class of risk. It's accelerating a fragmentation effect. We've seen this fragmentation effect in open source already, and it makes this expertise even more critical than ever. AI creates this illusion of completeness, and the tools default to vibe-coded solutions, bypassing robust libraries and creating a sea of noise. I don't want to frame this as a threat, but as a call to action. We need to move up the stack. We need to evolve our role from writing code to architecting the foundations of the new AI compilers. that everything will be built on. This requires an immediate triage of the existing ecosystem, but also an effort to build the new geospatial foundations for AI that everything will be built upon, and it's what I'm calling the foundry. So how did we get here? Well, it was just 4 years ago. It's hard to believe that it was just 4 years ago, 5 years ago, that Copilot was launched. This preceded ChatGPT, and this is where the AI-assisted coding really began. It showed that that AI could be used for not just autocomplete, but it could actually start doing more than one line at a time, and it could sketch out whole functions. Then ChatGPT was released, and coding became exploratory and conversational, and suddenly everyone had access and was able to do this, and it wasn't just the users of GitHub. GPT-4 pushes that to a new level. It could write coherent modules, it could reason across multiple files, and explain code in plain language. And this is when I think developers started trusting AI a little bit more than just with snippets. 24, 25, just last year, we started seeing more long context models, million token content. So now, instead of feeding code piece by piece, then developers, we could hand the model an entire repository and ask for a test suite or security review or a full refactor. I'm sure if you've used AI, you've had it refactor code and make 50,000 lines of change in that code, all in one shot. 23, 24, LLMs started scaffolding new repos. I think probably if you've used it, you've used it for this. Most new repos start with an LLM prompt, boilerplate structure, initial files, all generated by default, and then humans can jump in afterwards. Last year, we started seeing the specialization of models, so using different models for different things. Whether or not it was whole repo tasks or for brainstorming or quick coding, we see Claude and ChatGPT and the different flavors of Claude and Gemini. 2025, this year, GitHub releases Spec Kit, and that's a bit of a different direction than the models so far. After a couple of years here of like really loose AI outputs of this vibe-coded noise, we see maybe what is a correction, and I'll talk more about that a little bit later. I talked about geospatial, not special, and so for years there's been this debate about geospatial isn't special. We want to make it not special by integrating it into the general purpose data infrastructure. We've seen this succeed in GeoParquet. So the whole point of GeoParquet was that the community pushed for geospatial data types, geometries, to be part of the Parquet standard, rather than just a new isolated spec and a new standard with its own ecosystem of tooling. And so that is great for a maintenance culture which prizes reuse and reusability and a shared expertise. But here's the paradox, right? Is that the success of this depends on a deep shared domain expertise. And our core infrastructure, these libraries that encode this expertise, are used by thousands and maintained by a handful. But AI treats geospatial as not special like we intended. It doesn't have any domain grounding. It's not in the training data. If it's not in the training data, it will generate generic vibe-coded solutions that fail spectacularly on the complex realities that it does not understand. The anti-meridian Python package is a good example of this. It encodes complex, non-obvious logic about how to deal with the international date line. It's a special problem. It's solved by experts in various libraries. The Python package is one of these, written by Pete Godomsky. And the AI assistants, unaware of these edge cases, will always generate a bespoke fix that is brittle, naive, or flat out broken. The vibe solution fails the real world test by proving and proves that in the moments that really matter, the geospatial is in fact special. The main problem of these coding tools is that from suggestions to vibe-coded prototypes is that it creates an illusion of completeness. The generated code looks functional, it satisfies your immediate prompt, but it skips 90% of the hidden non-obvious engineering required for robust, scalable, and secure software. This isn't a new problem. Developers have always been capable of being lazy and foolish, but shipping untested code instead of using a proven library, you could always do. But the new problem here is that AI makes the foolishness itself scalable and effortless and invisible by hiding it behind this illusion of completeness. It's an accelerant for bad engineering. And this is Lal's cascade failure that Data created. It was the core of the problem. These vibe-coded fragments are Lal, an entity that appears fully functional and evolved, but it skipped the foundational, boring architecture. We're headed towards a cascade failure. Another way to look at this is the Dunning-Kruger effect. AI-generated code drops us straight into what looks like the plateau of sustainability because it is just so confident in itself. And we actually, if we're not domain experts, we can't actually tell if it's real competence or if it's the peak of Mount Stupid. The code looks complete, so we skip that learning that reveals what's missing. AI has masked that 90% of standards, edge cases, and robustness. It's an impressive surface, but a fragile core. The illusion here is the direct source of the fragmentation. Developers, especially non-domain experts, mistake a prototype for a solution, and this is the essence of vibe coding. It's a digital time bomb of invisible technical debt that collapses under real-world edge cases, all the while feeling productive. So why? Well, before AI, we had a discovery funnel where there was a certain amount of friction. A developer would search for a solution. They had to read blogs and tutorials and Stack Overflow that would move them into the valley of despair in the Dunning-Kruger effect. They would learn just enough to realize that they knew nothing at all. And this friction, while slow, it would funnel them towards expert, vetted, and robust libraries. But after AI, now we have instant generation. The AI bypasses this funnel. It provides a no-friction way with plausible-looking answers. And the developer sees working code and never thinks to search for the correct library, and the illusion of completeness takes over. So what does this mean over time? This isn't just bad code. This is an interoperability collapse. It's a sea of digital time bombs. Nothing works with anything else, and the signal of our shared robust libraries is completely drowned in the noise of a million fragile, bespoke fragments. This is already happening. This is a true story. On a project I was working at recently, we needed a features API. So what did a developer do? Ask ChatGPT to make a features API. It would serve features from a PostGIS database. The AI generated some lines of code that appeared to work. The developer saw a solution and said, we need to move this to production. They created an illusion. They completely bypassed battle-tested implementations like PyGeo API or TPG or GeoServer, which already have solved the invisible 90% problems, OGC standards compliance, filtering with CQL, complex geometry handling, performance optimization. This is a vibe-coded API that's fragile, and the problem is the AI only knows how to build these fragments. And we see more and more reports of the same problem. You see this in the news. There's a whole business now on Fiverr where people are making money fixing vibe-coded solutions. So we've been here before. This is Kathleen Booth. She wrote the first assembly language. In the 1950s, the priesthood of assembly programmers, these were domain experts. They held arcane knowledge, right, of the hardware. And they were confronted by the first AI, in a sense. It was the compiler. The arguments then were the same as now. The new tools were untrustworthy. How can I trust this? Its output was inefficient. I can do this better by hand by creating the code. And they were technically correct, but they missed the point. The compiler won because it was good enough. and it allowed us to move the value up the stack and be more productive. The true move up the stack. This history provides our path forward. Moving up the stack is to evolve our work from not writing the code, but to design the systems that guide the code's generation. This isn't a minor shift. The move from assembly to compilers created a whole new ecosystem. It created high-level languages, it created linkers and debuggers. This is our call to build a new ecosystem that AI can use to reason over and generate results. So, what do we do? Well, what we can do now, the immediate triage, is deliberate, high-leverage work to create a clear signal for today's AI. This means building and maintaining foundational libraries, writing clear, comprehensive documentation and tutorials, creating test suites, championing standards. If you thought that I tricked you into coming to this talk to just tell you to write better documentation, you're partially right. There's really no reason anymore for a bad README. The other day, had a project. I looked at the README. It was 1,700 lines long, and it started with migration notes. There's no reason for that anymore. AI is very good at creating READMEs. Might be a little bit verbose, but we can use that to create clear documentation and, in fact, READMEs that aren't just for humans, but for other AIs. This is not maintenance work. This is really important architectural work that we can do to now. We need to create the signal that the AI compilers can be trained on in order to be useful. But for longer term work, and I'm not entirely sure what this is that we need to architect the new system for tomorrow's AI. This is the foundry. It's a blueprint. Our knowledge has to be codified not just in Python, but in formal machine-readable specifications, the blueprints, that can be used as the primary source for AI. The goal isn't to just have a good library, it's to provide a spec that the AI can use to generate or validate the library's logic. This is the real lesson from tools like GitHub SpecKit. I don't know if SpecKit is the answer. We're still early on in here, so the answer is probably not. It's probably something else. But it seems like it might be at least a step in the right direction. So this is our new value. Writing Python code is someday probably going to be quaint, just like the priesthood of assembly code writers. But designing the specs that write the Python code is actually going to be the critical high-value work. This is not new. Generative design has been used for years in architecture and engineering. It shifts in software. We're really shifting from writing the code to defining the constraints. This mirrors how generative systems have used. Humans specify goals, requirements, materials, boundaries, and the machine explores many valid designs to satisfy those constraints. GitHub SpecKit, moving in the same direction, it forces AI code to align with explicit human-authored specifications before the generation begins. This is essential precondition for generative design. In other words, it's laying the groundwork for shifting software engineering from handcrafted solutions to architecting the space of possible solutions. In other words, we need to move from being developers to being designers. The argument boils down to these points. AI creates an illusion of completeness. The coding, from the single-line suggestions to prototypes, is brilliant at creating code that looks complete, but is in fact not. It skips the invisible engineering. By default, it fragments. It's going to fragment the open source ecosystem. It creates a digital time bomb of technical debt. It's biased by default to fragment, bypassing the discovery funnel that developers once used to deliver robust libraries. This is LOL's cascade failure. Subject matter experts become more valuable, not less. As AI floods the world with a sea of noise, the expert who can distinguish the signal and fix the cascade failures becomes the most valuable part of the ecosystem. The compiler's here. We must act now. Triage by writing that tutorial, improving the documentation, and add those test case and use AI to do so. But also next is we need to figure out what the next ecosystem of tooling looks like for AI to use. How do we build a machine-readable spec for the anti-meridian? So we're living in this moment that data feared for law, systems that look complete, they act capable, they move faster than we can guide them until they hit that part of the problem that requires real foundations, and the cascade failure begins. This is the risk facing software being written today with AI. The danger isn't a Terminator future where AI replaces us. It's the Sorcerer's Apprentice future, where our own tools flood the world. Each fragment feels functional, but it erodes the shared infrastructure that we all depend on. This urgency is real. We have to stabilize the geospatial signal, reinforce the libraries, and if we don't, we'll drown in a sea of vibe-coded brooms. But we also do have to admit something uncomfortable. We are building a future where much of the work that we do today disappears. That's the history of software. Every big jump in abstraction takes tasks that once required experts and turns them into the things that machines handle automatically. AI and generative design will push that even further. So yes, in a real sense, we are working ourselves out of a job. It just means that the generation that gets to we're the generation that gets to shape the rules, the values, and the guardrails before this work changes forever, and our roles shift from doing the work to defining the world in which the work happens. Thank you.
Thank you, Matt. We've probably got time for one or two questions. Does anyone have any questions? Wow, I generally thought people would have questions, but that's okay. Yes, one in the front here, Phoenix.
How long have we got?
We've got 3 minutes, so keep it. I mean, Matt will be around,
that's
so.
probably about right.
How long have we got for AI? You mentioned the compilers here.
Sorry.
Oh gosh, that's when the compilers first came about, they didn't believe in it, that it would work, that it wasn't efficient enough, that it didn't work, and that it was successful because it was good enough. How close do you think we are to being good enough?
I don't know. I told
very
you
hard to
I'm
say.
not an expert, but like, I mean, I think, the real risk here is that we are being flooded. Like, I'm sure that you all know that, like, the internet is the dead internet theory, if you're familiar with it. Like, it's being flooded with AI generated noise that will we actually be able to recover from that when models are being trained on information that other models have created?
Thanks, Matt. Just a reaction here, thinking about two things, my 2 cents there in terms of fragmentation. When dealing with AI, to generate code, right? Basically, you kind of break from the design. If you get a very complex problems, you break it down into, I think, what they call maybe building blocks or something, right? Mm-hmm. And then basically, I think that's the best approach. So I see from the positive side that fragmentation in that way is kind of leaning positively, right? And how you kind of leverage AI in that regard. The other point I wanted to raise is about spatial into geospatial. And I'm thinking that I think we got a challenge that we kind of wanted to isolate ourselves to be really treated as special. But actually, how the world works is that they just want insights or information from whatever data. The data could be spatial, or it could be the traditional one, right? And what I'm trying to say here is that the approach could be focused on trying to deal specifically with geo and remove that geo challenge for the traditional systems so that we can leverage the traditional system. So for example, if you got like data and get that data in a form that you could easily integrate that with the traditional systems that doesn't know how to deal with geo. So then we can get integrated into the existing systems. Just that's my thoughts there, and you can say something.
Yeah, no, thanks for those thoughts. I mean, there's certainly, like, I use AI, right? Like, we should all be using AI. Like, it's productive. I find that it doesn't necessarily take me a shorter amount of time to do stuff, but I feel like it makes the product better. But it's easy to be lazy. It makes it very easy to be lazy. Just like I said, it's an accelerant for bad engineering. And that's what we have to be careful about. So, like, breaking down the problem, it's don't do a refactor, create 30,000 lines of change code that nobody will ever be able to review, right? Like, break the problems down so that they can be reviewed line by line, and you understand what the changes are.
Thank you, Matt. Unfortunately, that's all we've got time for questions. I'm sure Matt will be around for the rest of the conference, so feel free to come up to him. For your head off, I do have to say two things. There actually are two additional, talks happening at 4:30. There's the Platinum sponsor keynote taking place in WG 403, and then there's a Geo AI Transformer session that's taking place as well at 4:30 at room WG 802. And with that, I call the session to a close. So give a warm applause to Matt's talk. Thank you.
Thank you.